Have you ever built something with Lego blocks? Object-oriented programming, or OOP for short, is a bit like that. It's a way to organize your code into reusable blocks, making it easier to build bigger and better programs. Think of OOP as a way to bring your code closer to how we see the world around us. Instead of just lines of instructions, we can create digital representations of real things like cars, animals, or even online shopping carts. But OOP isn't just about making our code look pretty. It's about writing code that is efficient, reusable, and easier to manage. And that's where the real power of OOP comes in. In object-oriented programming, or OOP for short, everything starts with a blueprint. This blueprint is a fundamental concept that lays the groundwork for creating complex software systems. This blueprint is called a class. A class serves as a template for creating objects, which are instances of the class. Let's say we want to create a program that simulates a dog park. In this scenario, we would need to define various elements that make up the dog park. We could have a class called Dog. This dog class would serve as the blueprint for all the dogs in our park. This dog class would define all the essential characteristics of a dog: its breed, its name, its color, and even its barking sound. These characteristics are known as attributes. Attributes are the properties that describe the state of an object. They help in differentiating one object from another. Now, a class is just a template. It doesn't represent an actual dog in our park until we create an object from it. To actually have a dog in our digital dog park, we need to create an object. An object is a specific instance of a class, complete with its own unique set of attribute values. An object is an instance of a class. It is a concrete entity that has been created based on the blueprint provided by the class. So, we can create a dog object named Fido, who is a golden retriever with specific attributes like breed, name, and color, and another dog object named Bella, who is a beagle. Bella would have her own unique set of attribute values. Each dog object has the same attributes as defined by the dog class, but their specific values like name and breed are unique. This allows us to create a diverse and dynamic dog park simulation. One of the coolest things about OOP, or object-oriented programming, is that it lets us reuse code in smart and efficient ways. This means we can build complex systems without having to start from scratch every time. This is where inheritance comes in. Inheritance allows us to create new classes that are based on existing ones, making our code more modular and easier to manage. Imagine we now want to add cats to our digital pet park. Instead of starting from zero, we can build on what we already have. Instead of creating a whole new class from scratch, we can create a cat class that inherits all the basic characteristics of the animal class. This saves us a lot of time and effort. This means our cat class automatically gets attributes like name, age, and sound. These are inherited from the animal class, making our code more efficient. We can then add cat-specific attributes like whether they have stripes or not. This allows us to customize the cat class while still reusing existing code. Polymorphism is another powerful OOP concept. It means many forms and allows objects to be treated as instances of their parent class. In our pet park example, both our dog and cat objects can make a sound. This is where polymorphism shines, but they make different sounds, right? A dog barks and a cat meows, each with its unique sound. Polymorphism lets us use the same command, like make sound, for both objects, but each object will respond with its unique sound. This makes our code more flexible and easier to extend. OOP, or object-oriented programming, is everywhere in the software we use every day. From the apps on your phone to the websites you browse, OOP helps developers build complex systems in a structured and manageable way. It allows for the creation of reusable code, making development faster and more efficient. Think about a shopping app. It likely has classes for user, product, and shopping cart. Each class has its own properties and methods. These classes interact with each other. A user object can add a product object to their shopping cart object. This interaction is seamless and intuitive. Inheritance and polymorphism make the app efficient and flexible. Inheritance allows classes to share common functionality, while polymorphism lets them be used interchangeably. OOP might seem a bit abstract at first, but as you start exploring it, you'll see how it can make your code cleaner, more efficient, and more fun to write. It encourages better organization and modularity. So go ahead, embrace the power of OOP, and start building your own amazing programs. The possibilities are endless when you harness the full potential of OOP.